What are the major sources of HFC emissions globally, and what are the main uses of HFCs and their drivers today and into the future?
Well, HFCs are all man-made chemicals. They are, for all practical purposes, completely the substitutes for various ozone-depleting substances that were phased out under the Montreal Protocol. And HFCs are used for air conditioning, refrigeration, and various other uses that CFCs and HCFCs were being used for. The big drivers for increases in these emissions is the increase in use of air conditioning, refrigeration, etc. in many developing countries who need such cooling both for comfort and for food preservation. Because of those increases in the use of air conditioners and refrigerations in various developing countries as the economies improve is the main driver for the increasing emissions of HFCs.
What would have been the contribution of HFC emissions without the 2016 Kigali Amendment, and how much mitigation is it expected to achieve in the next 2 decades?
Unlike CFCs and many of the HCFCs, HFCs are usually a little bit shorter lived, but there are many of the HFCs that are being used are indeed reasonably potent greenhouse gases. As an example, 134A, HFC 134A, which is a very major HFC that's being used, has a global warming potential of about 1,300. Compare that with CFC 11 of about 6,000 and CFC 12 of about 8,500. They're little less, but comparable. But the big thing was the increasing use of HFCs, as I mentioned earlier, is why the contributions of HFCs would have been larger because they can keep increasing in the atmosphere. So Kigali took a preventative step of not allowing HFCs to go way up, and in fact, to make HFCs go down by using other chemicals, both in kind and some totally different kinds of like natural refrigerants, to prevent the buildup of HFCs, which would have undone the gains made by the Montreal Protocol. If HFCs had continued to increase, we think it would have been contributing about 0.4 degrees to the global temperature change by 2100. And what Kigali Amendment did was to reduce that contribution.
Are HFCs still an issue now that we have the Kigali Amendment?
Good question. Yes, because Kigali Amendment has a phase down schedule, and that is what that actually could be improved upon. And also Kigali Amendment, just like in the case of CFCs, whose phase out was actually faster than what is required, and it actually was the same thing with HCFCs, it would be possible to meet the Kigali goals faster than what was agreed to in Kigali. And that is the big issue.
How substantial are indirect emissions of CO2 from energy production compared to direct HFC emissions from refrigerant and cooling equipment?
Well, recent EASA estimates indicate that the global cumulative hydrofluorocarbon emissions from refrigerant use in cooling technologies such as air conditioners, refrigerators, chillers, etc. will be over 360 gigaton CO2 equivalent between 2018 and 2100 in the pre-Kigali baseline scenario. In addition, indirect CO2 emissions from energy production of electricity used in cooling equipment will be approximately of the same order of magnitude if the world continues along its present path, and that is same fuel mix for power generation as today without any additional changes in policy. Therefore, we can say that transitioning to high efficiency cooling can double the climate mitigation efforts of HFC phase down under the Kigali Amendment to the Montreal Protocol, while also delivering economic, health, and other development benefits.
How much additional mitigation is possible by moving from the Kigali scenario to a maximum technically feasible scenario of mitigation? And what implications does this have for the climate?
Well, a full compliance with the commitments made by parties to the Kigali Amendment through replacement of HFCs with low GWP alternatives such as hydrocarbons, hydrofluoroolefins, ammonia, water, CO2, and other low GWP refrigerant blends means cumulative HFC emissions of less than 50 gigaton CO2 equivalent between 2018 and 2100. Thereby removing about 87% of cumulative pre-Kigali baseline emissions. With maximum technically feasible implementation of existing control technologies and without the delay in implementation built in the Kigali Amendment, cumulative HFC emissions could be as low as 13 gigaton CO2 equivalent between 2018 and 2100, thereby removing about 97% of cumulative pre-Kigali baseline emissions. Therefore, on top of the removal of about 315 gigaton CO2 equivalent achieved by enforcing the Kigali Amendment, there is a technical possibility for further reduction of more than 35 to 40 gigaton CO2 equivalent, which will make some additional contribution towards limiting the global temperature rise to 1.5 degrees centigrade.
So what are the implications for air pollution emission mitigation by moving to full compliance with Kigali phase down in parallel with the application of technically available energy efficiency technology?
Well, our estimates indicate that the reduced electricity consumption, it also means lower air pollutant emissions in the power sector. And we have estimated the reduction at about 5 to 10% for sulfur dioxide, 8 to 16% for NOx, and 4 to 9% for fine particulate matter emissions compared with a pre-Kigali baseline.
Where does HFC 23, which is a byproduct of HCFC production, fit into this broader picture of HFC management?
Under the Kigali Amendment, the compounds that were regulated were mostly the HFCs that were being used as substitute for CFCs or HCFCs, which were the first generation substitute for CFCs. HFC 23 is, as you said, a different animal. It actually is a byproduct of the production of HCFCs. And HCFCs and chemicals like that would still be produced in the future because there's feedstocks for other chemicals. And 23 is an unwanted byproduct of some of these productions. And if they're not destroyed, captured and destroyed, HFC 23 can contribute very significantly to the global warming in the future. Just as an example, the global warming potential of HCFC 23 is actually twice as large, or even more than that, of HCFC 12, which is phased out. And it is so important to capture and destroy them. So there's a major opportunity to avoid buildup of HFC 23, which would be a significant synthetic man-made chemical that need not be put into the atmosphere.